Okay, we have already discussed about titration. Now I have a question here. This was the same question that we were trying to solve yesterday. So I'm going to do this video to solve this question and show you how to solve questions based on this. Now in titration, questions normally don't come in this form only. They can come in this form. In this question, we are asked to look for the concentration of B in mole per dm cube and concentration of B in gram per dm cube. That is to say, you are given a standard solution and you are asked to look for the concentration of what an unknown solution. So that is one of the application of titration. You use titration to look for an unknown solution given a standard the concentration of an unknown solution when you are given a standard solution. Now I have said that a standard solution is a solution of known concentration, like the HCl that we have here. This HCl we have here is a standard solution because the concentration is 0.1 mole, 0.100 mole per dm cube. Now we can also use titration to look for water of crystallization. I think we are going to save that for another video. So let's quickly read through the question. The question goes thus: A is a solution is a 0.100 mole per dm cube HCl. B is a solution containing 2.50 gram of a mixture of Na2CO3 and Na2SO4 in 250 cm cube of solution. Now we have to take note of this, that this solution is not in mole in 1 dm cube. It is in 250 cm cube. So when we are working, we are going to convert from the cm cube to 1 dm cube or 1000 cm cube, from 250 cm cube to 1000 cm cube or 1 dm cube or 1 liter. Now the procedure is you should put A into the burette. A is the acid, so you put it into the burette and titrate it against 20.0 cm cube or 25.0 cm cube portion of B. B is now the base or the alkaline, using methyl orange as indicator. Now the reason why we are using a methyl orange, like I said earlier, is because the methyl orange is used for a strong base, a strong acid rather. HCl is a strong acid and NaCO3 is a weak base. Now they said we should repeat the exercise to obtain consistent titer values. Tabulate your burette readings and calculate the average volume of acid used. The average volume of A that is used. The A is the word acid. Then the equation of the reaction is given below. That is Na2CO3 plus 2HCl to yield sodium chloride plus water and CO2. This is the end product of a neutralization method because a salt and water is formed. Now, it may interest you to note that in that mixture of the base NaCO3 and Na2CO4, it is only the Na2CO3 that was used. So it means that this other portion of it was not used during the reaction. Now what we are going to do to get the concentration of B in mole per dm cube. Now remember that I have not performed the experiment here, but I am going to choose an average titer value average titer value of, let's say, 10.5 cm cube. So what am I going to do? So if I'm choosing an average titer value of 10.5 cm cube, I will try as much as possible to manipulate this value to form a table for myself. So I'm going to do this. I'm going to have rough, I'm going to have first, I'm going to have second, then I'm going to have third. Now I'm going to have, on this, final volume in cm cube. Then I have initial volume in cm cube. So I'm going to work towards my 10.5 cm cube. So what am I going to do? Let me take my rough. I'm starting from 0.00. Then during my titration, I can say 11.00 cm cube. Then my initial value is going to be 11.00. Now, because I remember I said that your burette is 50 cm cube, so we can still get up to like 11.00 out of this. Now I want to do this. I want to make sure that my first, second and third reading are more accurate than the rough, so I can get something close to 10.5. So what do? I'm going to add, let's say 10.6 to 11. So if I add that, I'm going to get So I'm going to get 21.6. So I have 21.60. Now what have I done? I have been able to manipulate this upward. Now I can take this to 21.60 as my initial volume now. Now I want to get a value that is close to 10.5 again. Let's say I'm taking 10 10.4 plus 21.6. So I'm going to get 32.00. Now I may decide not to start from here again. I'll say let me fill my burette again so that I'll fill it to 1.00. So to get something close to 10.55, what am I going to do? I'll just do this 10 point. Let's say I want to get exactly 10.5 plus 1. That will give me 11.50. Now you see that I have been able to manipulate this table. So what am I going to do? I'll take the difference between all of this. This is going to be 11.00. Then I have 21.60 minus 11.00. That will give me 10.6. Now you see that I'm going back to where I started from. What I added to this is what I'm getting back here. So I will do this again. 32 minus 21.60. That will give me 10.04. 10.40 rather. Then the last one, I know that when I subtract 11.50 from 1 point, I'm going to get 10.00. So my average title value is going to be the sum of the first plus the second plus this is 10.50 divided by 3. So when I do this, I'm going to have 10.60 plus 10.40 plus 10.50. I will have this 31. So I have 31.50 divided by 3 divided by 3. That will give me 10.50 cm cube. Now you see that from my manipulation, I even arrived at 10.50 cm cube again. I can get a value that is not 10.50 cm cube. I'll be able to manipulate so that I can get values that are close to 10.50 cm. So if I get 9.90, I am in order. If I get 9.80, I'm in order. If I get 10.5, 10.6, 10.7, and in that order, I am also what? In order. Now what do we do? So we go back and calculate for so we have gotten this. So this is the first thing that you have to do. Now we have the volume. So volume of acid. Now we can now go to the first question. Concentration of B in mole per dm3. So let's see. Concentration of B in mole per dm3. So what do I do? I'm going to use this formula. Let me write out the concentration of A from the question is 0.100 mole per dm cube. The concentration of B from the question is not given, so that's what we are looking for in mole per dm cube. Volume of acid used is the one we calculated. We have 10.50 cm cube. Volume of base used, we either use 20.0 cm cube or 25.0 cm cube. But you know, you have already stated this from the beginning. Like I said yesterday, we always normally use 25.050. So I'm going to use 25.0 cm cube. Then now we are going to look at the mole ratio. The mole ratio of the acid Na equals, now this is the acid, that is 2. The coefficient of HCl here is 2. So I have Na is 2. Then I look for the coefficient of base. This is the base. It's just 1. So Nb is equal to what? 1. Now we are going to apply the formula. We are going to apply this formula to get the concentration of the base in mole per dm. So I'm going to do this. I'm going to have this is the formula: Ca Va over Cb Vb equals Na over what? Nb. So from our table that we wrote down, we know that the concentration of acid is 0.10. So I have 0.100 times the volume of acid used was the average total value, 10.50, divided by the volume of base Cb times, the concentration of base Cb times the volume of base, which is 25.0. So we have 25.0, which is equal to the mole ratio of the acid is 2 and the mole ratio of the base is what? 1. When I cross multiply, I'm going to have Cb. I'll just take Cb and bring this one down here. Just take Cb and bring it down. So I have Cb equals 0.10 times 10.50 divided by 2 times 25.0. So Cb is equal to, so if I multiply, I'm going to have 0.100 times 10.50 equals 1.05 divided by 50. 2 times 25 is 50. So divided by 50, that's going to give us 0.021 mole per dm cube. So it means that concentration of B in mole per dm cube is equal to 0.021 mole per dm cube. That's 1. Now 2, concentration of B in grams per dm cube. Now we know that concentration in mole per dm cube is equal to concentration in grams per dm cube divided by molar mass. So the concentration in mole per dm cube is 0.021. Okay, we can do this. Concentration in grams per dm cube equals concentration in mole per dm cube times molar mass. And from the problem, we are given that the concentration, the relative molecular mass of Na2CO3 is 106. So the molar mass of Na2CO3 is equal to 106 gram per mole. So let's do this now. So therefore, concentration in gram per dm cube is equal to the molar mass, the concentration in mole per dm cube. So by using this formula, concentration in mole per dm cube, which we calculated to be 0.021 mole per dm cube times the molar mass, that is 106 gram per what? Mole. So when we do this is going to give us 0.021 times 106, that is 2.226 gram per dm cube. That is the number of that is the amount of moles present in gram per dm cube. Then the next part is we should look for the percentage of Na2CO3 in the mixture. Remember I said that we have a mixture of sodium triazocarbonate 4 and sodium triazocarbonate 4 and sodium tetraozosulfate 6 in the mixture. But from the equation of the reaction, you'll find out that it is only the sodium triazocarbonate 4 that reacted with what? The acid. So let's look at the percentage of that is present. So 3. Percentage of Na2CO3. Now we are going to do this. We have two alternatives that we are going to use, two methods. So let me use method 1 first. Method 1. Now remember that in the question, this solution A was given in mole per dm cube, and B was not given in mole per dm cube, but rather it was given, we are told that this contains 2.50 gram in 250 cm cube of what? Of the solution. So we have to convert this to mole per what? Dm cube. So if from the calculation that we did here, from this calculation that we have here, this value here is in mole per dm cube, you can clearly see that it is in mole per dm cube. The reason being that this one was in what? Mole per what? Dm cube. So now what we want to do is that we are going to find the amount, and this one is also in gram per dm cube. So we are going to find the amount of the mixture that is contained in gram per dm cube, given that we have it given in what? 250 cm what? Cube. So what I'm going to do is this. I'm going to say 1000 cm cube, that is 1 dm cube of B contains the value that we calculated, 2.226 gram per dm cube. Now let us look at the amount that will be present in 2.50. That will be present in 2.50 of the mixture. 250 cm cube of the mixture. So 250 cm cube of B will contain X. So if you cross multiply, I'm going to have 1000 times X. 1000x is equal to 250 times 2.226 gram per dm cube. So this is in cm cube. So x is equal to 250 cm cube times 2.226 gram per dm cube divided by 1000 cm cube. So this will cancel out this. So S is going to give us 250 times 2.226 divided by 1000. So that's going to give us 0.5565 grams per dm cube, or 0.5565 grams. Now let us look at so this value here, this 0.556 grams was the amount of in grams of Na2 that reacted with the acid. So from there we can find out that, yes sir, we can find out that now we can find out that only 0.5565 grams of the whole mixture, which is 2.50 gram, actually reacted with what? The acid. So we are going to find that percentage now. So percentage of B is equal to this mass 0.5565 divided by the whole mass 2.50 times 100. So that's going to give us 0.5565 times 100 divided by 2.5. So I have 22.26%. So that's the percentage of the acid, the base that reacted, of Na2CO3 that reacted with what? The acid. Now we can also use the other method to get that. Now method 2. Now for the second method, I am going to do this. We know that 250 cm cube of B was equal to 2.50 grams. We know that, right? Then 1000 cm cube, so I'm going to have to convert it to what? 1 dm cube. 1000 cm cube of B will contain X. So if I cross multiply, I'm going to have 250X equals 2.50 times 1000. So S is going to give us 2.50 times 1000 divided by 250. So if I do that, I'm going to have 2.50 times 1000 divided by 250. That is 10 grams. So 10 grams per dm cube. Now you see that the amount of the acid, or the amount of the mixture present in 1000 gram is 10 grams per what? In 1000 cm cube or 1 dm cube is 10 gram per what? Dm cube. Now remember that this is for the whole mixture, Na2CO3 and Na2SO4. But in our calculation, we found out that the amount of Na2CO3 that reacted was 0.5565. So the percentage of Na2 present would be 0.5565 divided by the total amount that was there. So I'm going to have percentage of Na2 CO3 is equal to 0.55 0.5565 divided by 2.5 times 100. So I'm going to have this 0.5565 times 100 divided by 2.5, which is equal to 22.26%, which is the same as before. So this is the method. This is what you can do, or this is the step that you're going to take to get your answers. Now remember that I still have to go back to this. Remember that I did not actually carry out the experiment, but I choose an average total value, or the volume of acid used. Then I was able to come up with what? This. I was able to manipulate it to get what? This. Okay, so I'm going to send you some more questions on this so that you work on them.